Welcome to the class of Applied Mechanics. I am A. K. Upadhyay. Before starting Applied Mechanics, let me to tell you about the books and the syllabus. Number of books are available in the market in the name of Applied Mechanics, but I will follow the book I have written. The name of the book is Applied Mechanics by A. K. Upadhyay, and the publisher is S. K. Kataria and Sons, Delhi. Regarding syllabus consists of the following chapters. Number 1, laws of forces. Number 2, moment. Number 3, friction. Number 4, center of gravity. Number 5, moment of inertia. 6 is laws of motion, and the last chapter is simple lifting machines. Now, what is applied mechanics? As you can see, applied mechanics consists of two words. One is applied, another is mechanics. Now, what is mechanics? Mechanics is the branch of science which deals with the study of action of forces on bodies. In other words, mechanics deals with the behavior of forces and their effects on different bodies. Now, if you apply these laws of mechanics into the solution of any engineering problem, then that study is known as applied mechanics. So, applied mechanics is the branch of engineering which deals with the study of application of different laws of mechanics for the solution of various engineering problems. Now, the importance of applied mechanics is that the knowledge of applied mechanics is very important, which helps us in the design of all types of structures and machines. So the knowledge is very essential for the design of structures and machines. Now applied mechanics has two branches. One is statics, number two is dynamics. Statics is the branch of applied mechanics which deals with the action of forces on bodies at rest, and dynamics is the branch of applied mechanics which deals with the action of forces on bodies in motion. Again, dynamics has two parts. One is kinetics, another is kinematics. I'm not going into the details of dynamics because this is not in the course of diploma. Now, for applied mechanics, a body has to be a rigid body. A rigid body, a body which does not change its shape and size on application of force, then this type of body is known as a rigid body. Actually, in the universe, it is very difficult to get a perfectly rigid body as some changes takes place in the body under the action of external forces, depending upon its shape and size. But these changes are very small as compared to the size of the body, and so the body is considered as a rigid body. For example, you take a wooden duster. If you apply force on this duster, will it change its shape and size? The answer is no. But if you take a rubber ball and you apply force on it, it changes its shape and size. So the wooden duster is a rigid body, whereas the rubber ball is not a rigid body. Now let us start with the chapter laws of forces. Now what is a force? Any pull or push which when applied on a body and which try to move the body or moves the body, try to stop the body or stops the body, then this pull or push is known as force. The unit of force in SI unit is Newton. All of you know this. Now you know force is a vector quantity. That means it has magnitude and direction. But to know a force completely, you need four quantities. And these are known as the characteristics of forces. These quantities are magnitude, direction, which you have already known. Third is line of action. Fourth is point of application. Now in this figure, a force of 10 Newton is acting. The Number 10 Newton is the magnitude. The air weight of the force shows the direction. Point of application and the line of action of the force is shown in the figure. Types of forces. Forces are of three types: tensile force, compressive force, and shear force. Now, what are tensile forces? Suppose you have a spring and we are applying two equal and opposite forces as shown in the figure, and due to this force, the length of the spring increases, then this type of forces are known as tensile forces. So, if two equal and opposite forces acting on a body having the same line of action and has the tendency to increase the length of the body, then these forces are known as tensile forces. Compressive forces. As shown in the figure, you have a spring. Two opposite and equal forces of magnitude P are acting on this spring. Due to this force, the length of the spring decreases. So, then this type of forces are known as compressive forces. So, if two equal and opposite forces having the same line of action and which tries to decrease the length of the body, then these forces are known as compressive force. Now, shear forces. Shear forces in which the line of action of the forces should be parallel. The forces are not acting on the same line, but they are acting on two parallel lines. In the figure, I have shown that two plates are joined by a rivet, in which equal and opposite forces of magnitude P are acting. You can see that the line of action of the forces are different here. Line of action of the forces are different. The line of action of the forces are different. Here, for this plate, the line of action of this force is this, and for this plate, the line of action is this. Now, due to these forces, the two plates slide over one another, has a tendency to slide over one another, and due to this tendency, the rivet ruptured, that is, it breaks, and the two plates move in outward direction. Now, this type of forces are known as shear forces. So, if two equal and opposite forces having different line of action and have the tendency to slide the body over one another, then these forces are known as shear forces. Now, next is force system. If a number of forces are acting on a body, then we can say that a force system is acting on a body. Now, force system is of two types. One is coplanar force system, another is non-coplanar force system. Non-coplanar force system is also known as A's force system. Now, coplanar force system. Coplanar force system Coplanar force system has four parts. One is called coplanar collinear, another is called coplanar concurrent, another is coplanar parallel, and the last one is coplanar non-concurrent and non-parallel force system. Now, what is coplanar collinear force system? When forces in the when forces in the force system lie in the same plane and have the same line of action, then the force system is called coplanar collinear force system. As shown in the figure, two forces F1 and F2 are acting, and they are acting on the same line. So are known as this type of force system is known as coplanar collinear force system. Next is coplanar concurrent force system. As shown in the figure, four forces are acting on a body, and the line of action of these forces are passing through the same point A. Then this type of force system is known as coplanar concurrent force system. So, if in a force system, forces are acting in the same plane and are acting through the same point, then this type of force system is known as coplanar concurrent force system. Coplanar parallel force system. The force system in which the forces lie in the same plane and the line of action of the forces are parallel, then this type of force system is known as coplanar parallel force system. In the figure, there are three forces acting on a body. The line of action of these three forces are parallel. So this type of force system is known as coplanar parallel force system. Coplanar non-concurrent and non-parallel force system. The system in which the force system in which the forces lie in the same plane but does not pass through the same point and the line of action of the forces are not parallel, then this type of force system is known as coplanar concurrent and non-parallel force system. In the figure, three forces are acting. The line of action of all the three forces are not parallel, and the line of action of these forces are not passing through the same point. So this type of force system is known as coplanar, non-concurrent, and non-parallel force system. Now, components of a force. What do you mean by the component of a force? Suppose a force is acting on a body, and due to this force, the body is moving 10 meters. So this is the effect of this force on the body. Now, if you remove this force and you apply two forces on the body, two forces in different directions on the body, and if due to these two forces the body is again moving 10 meter, then you can say that these two forces are the components of the single force. So, when a single force acting on a body is replaced by two forces and the effect produced by the two forces is the same as that of the single force, then the two forces are known as components of the single force. Now, components are of two types. One is mutually perpendicular or orthogonal components. Second is non-perpendicular components.